Well, howdy there, Internet students. This is Mr. Hermanson here. We're going to start a bit of a new lesson here on 1.2, and it's on slope. Now, I know you have a little bit of experience with slope, but in algebra, you really need to have a good grasp of what slope is, and actually in all your math classes. Um, so, so let's talk a little bit about what slope is, and we'll spend a couple days doing this. Okay, now some places where you may have seen slope or heard the term is roofs. When a carpenter is creating a roof, it has a certain slant to it, and so that's called a slope. And it's given by how how steep it is. So it's a number that represents how steep that, and it's given as a fraction, and sometimes it's called the pitch of the roof also. When you've been skiing, you have talked about the slope, the ski slope, and some slopes are steeper than others. You may have seen this black diamond or a double diamond, and that represents a steeper, where a circle represents a really easy, and so on. And those are some ways to describe the slope. You may have seen this sign. I know one place I always see this sign is when I'm going to the town of Duluth, Minnesota. I actually, in Duluth, it's a 6% grade, but it's a warning that the road is pretty steep. Now remember, a percent is also a fraction out of 100. So what that is telling you is that you are going down 8 feet for every 100 feet you go across. And that's a pretty steep road. Okay, in lots of science things, we use slope to represent different things here. These are some things you might see in a science class or another math class. Slopes can change as you go. Notice the slope of this motorcycle getting steeper. Now it's kind of reversing. That's a negative slope, another negative slope. You actually would need calculus to get the slopes for changing lines like this when the line's a curve. Um, and now he's almost back to, um, now he's a positive slope. Anyway, and a lot of business things we talk about slope, and slope are the costs per item or unit or hour or whatever. So we use lots of slope, and I'll just give you a quick example. We can count how far down it is between these, which is 5, and then how far over between the dots, like that. And the direction of this line is negative, so this would be a negative slope, and it's negative 5 over 40. I think it's 40. Um, we can simplify that to 1/8. As a decimal, it's negative 0.125. And what that's saying is the cost of production per chair is going down by about 12.5 cents per chair produced. So the costs go down as you produce more chairs, which kind of makes sense. Okay, I want you to try and discover for yourself what slope is. You've probably seen stairways and ramps, things like that. What I'd like you to decide is maybe order these different stairways and ramps from least to greatest. Just kind of take a guess, and then I'll show you how you could more easily figure out which is the steepest. Like, I think most of you agree that this is the steepest ramp here. That's pretty easy to tell. But try and order them from the least steep to the most steep. Good time to pause here. Okay, so that's kind of hard. You probably found out. Now let's not worry about whether it's a negative or a positive. Like this slant here is a negative because it's decreasing. Where if you look at the slant here, it's in a positive direction on a graph. But let's not worry about that. Now here's a suggestion. If you could measure the distance up and the distance over and write that as a ratio, what you would notice is that the higher the number, the steeper the line. Let's just compare these real quick. This one goes up. I think it's 9, isn't it? Yeah, it goes up 9 over 3. And if I write that ratio over i's over run, 9 over 3, that's the number 3, where diagram A is up 2 over 4, which is 1/2. Now, 3 is definitely a bigger number than 1/2, and so that's going to be a steeper line. So what I'd like you to do is pause right now and go ahead and put a dot from between the two spots on each diagram. Draw a horizontal line between your dots and a vertical line between your dots. Find the length of the vertical line and the length of the horizontal line, and then write that as a ratio in simplest form. So I'm going to reduce that to 3/5, and then try and figure out which of these diagrams is steeper. So this is a good time to pause. Go ahead and do that and find your ratios. All right, so here's the numbers I came up with. Like now I can tell that this one is steeper than this one pretty easy, because this number is greater than 1, this number is less than 1, right? If you want to get a real accurate sense, you could change them all to decimals. This one you should have gotten 1/2, and this one up here, we already did those. All right, so that's how you use rise over run to find the steepness of a line. Now, so just so you know, this line right here has this slope 7/12. This line right here has this slope 4/3. This line has a slope, this is actually a negative, so it would be a slope of -1/2. Likewise, this slope is -3/5, and so on. All right, so let's just go over some standard practices for finding slope. M is the letter we use for slope. It's pretty confusing why that letter N came up, but I think it has something to do with the Greek alphabet, but we don't really need to get into that. So there's some ways you can tell how you find slope. First of all, it is a ratio. It's the vertical change over the horizontal change. So this is another way we can say it, vertical change, or how far up, in case you forgot what vertical means, over horizontal change, how far across. The slope represents the rate of change. It should be written as a fraction. That's not a super fixed rule, because sometimes we use a decimal. A fraction, if you do put it in a fraction, then please put it in lowest terms. Okay, so simplify that fraction, basically what we're saying. And I'm going to erase this and then actually give you a formula for finding slope. Now, when you, and I'll show you this in a second, but if you take your y coordinates, which are your up and down coordinates on the y-axis, so take your two y coordinates and subtract them. Now you have two different y coordinates, so I'm going to subscript them with a 2 and a 1. There's nothing mathematical there, that just means you have two different y coordinates. And if you subtract them, that's how far up you go. And likewise, if you take the two x coordinates and subtract them, that's how far over you go. So this is up, this is the distance over, and you can use those two to find the ratio. And I'll show you that right here. Okay, so just so you can see how that works here, this coordinate right here is 4, 0, right? This coordinate here is -2, 3. Now, to get this vertical distance, the length of this line, which you guys can see it's 3, that's no big deal. But you could also take this number here and this number here and subtract them. 3 minus 0. And that's what this is saying. Okay, and then to find the distance across this, well, that's easy to tell, that's 2. But you can always also get that distance by subtracting the x-coordinates. This, whoops, I put that wrong, that should be -4 and -2. So if I do, and I always do the biggest one first, if I do -2 minus -4, that's equal to 2. So if you don't have a graph, or if the numbers are decimal or pretty big apart, then you can do that by subtracting the coordinates. Okay. The other way you can do it is just by counting the units on the coordinate plane. So real quickly, you could just draw this line, draw this line. This is over 2, and this is 1, 2, 3, 4, 5, 6. And then it's rise over run, so we need this 6 goes first over 2. Then you have to look at the direction of the line. This is a negative slope line, so we put -6 over 2, which is -3. Why don't you go ahead and try this one here. Do that rise over run, see what you get. There you go. You should have got that. All right, I'm going to erase this so we can use this graph for number 1 and number 2 here. Okay, it says find the slope between the 2 points. 3, -2, so that's 3, -2, that's right there. Maybe I should use a different color here. Red. 3, -2, and then 4, 4 is over 4, up 4 right there. So we're going to draw on that line. Okay, and we're going to do a rise and a run. So count that distance, that's 1. Make sure those lines are vertical when you draw them, the rise and the run, and horizontal. And looks like 6 over 1, so our slope is 6 over 1. If it's over 1, you could just write it as a whole number. Okay. All right. And now the other thing you could do is use this little formula here. To do that, you would take your 2 y coordinates. That's your rise. So you're going from -2 to 4 and subtract. And I always subtract the smaller one from the bigger one. Nope, I said that wrong. I don't always subtract. You have to subtract them the same way. So if I do 4 minus -2, then I have to do 4 minus 3 for the horizontal change. And we get 6 over 1, which is exactly the same. So let's do one more here. Let's do 0 minus -1 on top. That's the rise. And since I put the 0 first, I want to put the 6 first for the run, from 6 minus -8. And 0 minus -1 is 1. Remember that taking away a negative is a positive. And 6 minus -8 is 14. So 1/14 is that slope. All right. I think I'm going to stop right here today, and I'm going to give you a few homework problems to do today, and then tomorrow I'll go over the last part of this, and we'll talk a little bit more about slope, and then I'll give you a few more problems to do. All right. Good luck with that. We'll talk to you soon.